Hello and welcome to my individual reflection thread. My name is Richard Bassett. I am a Senior Research Associate at Lancaster University and I work on a project named Ensemble. And I thought I'd talk to you today about something that really is the nature and the meaning of ensemble. So I'm going to talk to you about a thread or a piece of work I've done, which is looking at quantifying internal model variability within the Wolf numerical model. And I'll try and break down what that means and then show some of the results of our study. So when we're modelling weather, we typically run kind of a model encompassing the whole globe. We set the model free running, and after a few days, we lose kind of accuracy in our forecast. Chaos theory takes over, and we're no longer able to get a good prediction of the weather, what the weather might be, and this typically is kind of over a week in length. But for kind of scientific applications, when we're running models offline to look at processes within the model or run past case studies, we typically run a nested set, a smaller model, and take input from that larger global model. And we take kind of past weather events that have already happened to run our model. So really, in theory, there shouldn't be much kind of chaos theory going on because we already know the kind of the wider meteorological patterns that have occurred in the past. So models, the one we're using in the study called WRF, the Weather Research and Forecasting Model, can be run for a wide range of applications. I've been using it to simulate urban heat islands, but you can run all sorts of weather, thunderstorms, forest fires, anything you want to do. There's a wide range really. So typically in those research studies, they run a single simulation, and that is gospel, that is the answer. But what we've shown in our study is that if you run more than one simulation and change things ever so slightly, in our case just the start time, we get a different answer. So which answer is correct, really? So we get back to an ensemble here. We created a large ensemble with this model. We ran what we call 244 members or 244 different simulations. And each one we simply changed the start time by 6 hours. And then after a period of a couple of months, we had all our simulations running for kind of another kind of 2-month test period. And for this, we just ran a simulation centred over the southeast of London because I guess I've got a focus on urban heat islands, so it was really wanted to explore those a bit more on the uncertainty in modelling. So this is just a snapshot of our simulation, and you can see the red lines kind of grow. And this is for temperature. The dots are observations, and you can see after a certain period of time, we're getting lots of different answers, and up to about 8 °C difference. So what do we think is causing this? So we looked at the input conditions, so we had the smaller domain, and that takes input every 6 hours at the boundaries. So when we've got kind of slow wind speed conditions at the boundaries, because conditions are updated every 6 hours, this, I guess, chaotic processes take over within the model, even in this short time period, which leads to kind of a diverge in the members and the results we get. But when you get wind speeds, high wind speeds at the boundaries, they kind of dominate, kind of flush out what's happening within this smaller domain. So we get less divergence between the members. So why is this important? Well, in a sense, if we're just running a single simulation, how can we trust that? We need to kind of give some estimate of uncertainty. But equally, running 240 members is not practical. That takes a large amount of computing time. Sorry. So this instance took over 240,000 CPU hours, and that's very expensive. It takes months to run that. So we kind of delved into the results, and we found for this simulation, other simulations may vary, but we needed about 30 members to really adequately explain all the uncertainty in the simulation, so we could kind of look at ensemble means within that. So if you'd like to find out more about the study, there's a link at the bottom. Please read, and my email is r.bassett@lancaster.ac.uk if you'd like to contact me and discuss further. Thank you for listening.